Welcome, everyone. My name is Nate Daly. I'm a principal enterprise architect with MITRE. I'm going to present today on a global framework for cross-policy techno architecture and automated anomalous space behavior detection. As this background slide states, many of the issues that face us today are a result of uncoordinated presence in the use of space by nations and private enterprises. Uncoordinated, what I mean is by design, the organizations that are responsible for different components and pieces of the space domain grew without intentional design 50 years ago. And so, in short, regulatory mechanisms and administrative mechanisms that were originally designed to handle individual components of the space domain have grown to be self-constraining and in some cases defeating because they just weren't designed to handle the challenges that we face now today. The Government Accountability Office found a few years ago, I think in 2008, a report on the fragmentation, overlapping, and duplicative regulatory mechanisms. For example, FAA has launch authority, the Federal Communications Commission has satellite operations licensure requirements that were placed in their control because of spectrum management. But NOAA also has operations licensure requirements based on equipment on the satellite, whether you have remote sensing or not. And then, of course, we have the Office of Space Commerce now that is trying to catch up with a very rapid past decade of commercial evolution. At the same time, the international landscape presents us with a challenge. Now, our U.S. national space strategy has a peace through strength vision, but I'm also going to talk a little bit about balancing that peace through strength with peace. Let's not forget about the peace part. So peace through strength and friendship. So ex amicitia paz, literally the motto of the U.S. diplomatic corps. And you'll see that on a lot of diplomatic invitations, for example. So there's this balance between peace through strength and peace through friendship that I think is lacking in the discourse today, and I'll want to address that a little bit. One way to determine whether we won a war in space is to not have had one in the first place, and so there is not a peace through strength or peace through friendship component also coupled that could present a problem. And simply the fact that we are experiencing these self-constraining and defeating constraints within our administrative mechanisms, it's hard. It presents a problem for the U.S. at an aggregate level. Some people have said that we feel like the U.S. is flailing with this particular problem. So a global framework for cross-policy techno-architecture couples the policy world and the technology world. It literally digitizes space policies in ways that we can extract artifacts for vocabularies, for standards and specifications, so that our architecture and that our policies are up to date with the current trend and current evolution of technology by creating this funnel, this way to continually refresh policy with current vocabulary, and vocabulary that spans across multiple domains: public, private, academic, and international. So the landscape of normative behaviors among states and independent actors alike are just as important as the astrodynamics risks associated with space traffic management and orbital debris. And so a global framework in architecture is a way that we can move forward to connect the policy world with the technology world. We are accustomed to developing architectures that are based in requirements. But before I get there, let me just mention that agreement for operation is necessary too. And so when it comes to agreements, transparency that leads to confidence building measures that leads to trust are very important. And so a definitive understanding of what the vocabulary is fundamental, not just for any architecture, but for any international agreement as well. So enterprise architectures and reference architectures are literally strategy plus business plus technology that are typically based in mission requirements, based around mission requirements. But for a socio-technological architecture, Mission requirements are a little bit different. Here we calculate the formula for this type of architecture is technology plus vocabulary plus policy. And because it's socio-technological, it's cross-cutting. It is better suited for linking innovation and social and environmental impacts driven transformations. The traditional regime for mission-driven innovation is great for tracking requirements, but we find ourselves now needing a new paradigm for bringing to fruition things like sustainable development goals and the 21 long-term sustainability guidelines for space that were based in work that was done around the 2011-2012 timeframe by the United Nations group of government experts on transparency and confidence building measures for outer space. Those are sorts of impacts that we would want to drive to help balance a peace through strength and peace through friendship approach. So here's a diagram of what this sort of looks like, how technology informs vocabulary vis-a-vis artifacts like data dictionaries and lexicon, and how data dictionaries then inform policy and policy formulation methodologies. And those policies then drive, if we do this right, the types of good normative behaviors in the landscape of space activities that we want to see, and mitigates the bad normative sorts of behaviors that could evolve. For example, ASAT testing. Moving on, I mentioned agreements earlier in the briefing. So linking to a blockchain system that enables space traffic awareness is one way to, with immutability, lock down a state or a change in state that allows for transparency that then can lead to confidence building measures and trust. What makes this really interesting is that if we have these smart treaties, for example, what makes that particularly attractive is that on the one hand, a blockchain sort of awareness system can validate with immutability space objects as a space situation awareness or space traffic management support system. And on the other hand, a codified global framework together with the blockchain awareness system allows us for comparing that SSA and STM data in space with these codified smart treaties, and in a sense creates a system for automated discovery of anomalous behavior and smart treaty compliance in international affairs, because the desired behavior has been digitized and then coupled within this architecture. So how do you make that happen? So the methodology that I have been undertaking in doing that is to conduct a policy literature review that spans the peaceful use of outer space sorts of policies and treaties, as well as military doctrine, to combine both military space power and national at an aggregate level, and then to create a taxonomy and a policy map that I can then use to identify these themes, to develop a logic model, and then within that logic model, if we begin with the end in mind, the desired impacts, we can backtrack to the sorts of activities that have the deliverable outputs that have the outcomes that then drive to those impacts. The important thing about that, and I'll get to that in a moment, is that an activity model is literally where the rubber meets the road for architectures. So some of the documents that I have been looking at more recently are listed here on this particular slide. And then just for illustrative purposes, here's what that taxonomy policy like. And you can see a lot of arrows pointing to the third column from the right, which is the thematic column that I've been able to derive from the objectives and goals of all of these different policies. And so at a very high level, in a grand strategy sorts of level, there are these 7 sorts of impacts, grand strategy level impacts that I've identified to strive towards are balanced across military space power and the aggregate level of national space power. Sharing a vision for space utilization and exploration, building resilient, secure, and ready links for cooperation. Number 2, for example, crafting new mechanisms for close cooperation that crosses governments, universities, and industry. Impact number 6. And so in the end, which is the next slide. First, let me get to the activities. So these are the activities that then, if you backtrack from those impacts, would support those impacts. And this is important because now we can craft an OV5 architecture, so an activity model or a process model. What's important about that is, coupled with a good data architect, we can also create a data model from that vocabulary. So we now have the verbs, and we now have the nouns codified in the form of an architecture that describe in an architectural way the sorts of activities and the sorts of vocabularies that are going to be needed to meet those desired impacts. Put all together, here are those activities that lead to those outputs, outcomes, and those particular impacts. And so this is the methodology that went behind this sort of study that I'm currently conducting. The next question is, how do we organize to make that happen? Well, it's somewhat of a process, and it looks somewhat like this, where you would tap resources or staff support from various organizations across the machinery of government to participate in a team-oriented sort of organizational design to carry out this process. And it requires organizational liaison across individual spacefaring and space-related organizations, compiling themes and developing messaging and vocabulary, architecting those into artifacts for our comprehensive architecture, and then doing something with it. So engaging internationally, multilateral forums like the Scientific and Science and Technology Subcommittee of the United Nations Committee for the Peaceful Use of Outer Space, or the Subcommittee for Space Law as well. Here are those activities embedded within that process that was on the previous slide. And then the next question is, how can the U.S. organize to make that process happen and to make those activities happen? There are three typical sorts of ways to create an organizational design. One is a hierarchical or a bureaucratic, that's traditional. Another is a matrix, but for this particular one, what we have experienced, as I described in the first few slides, is the runaround. You got to go here, you got to go there to get certain licenses and approvals. And that's what we traditionally call the runaround. And so for that particular problem, a one-stop shop sort of team design is best oriented to support processes, not only processes, but also life cycles in ways that you can address problems in one particular forum or one particular organizational design more effectively. And I think that this is what we are looking at as far as a need goes for the U.S. government, whether it is a integrated project team or an intergovernmental IPT, or perhaps a U.S. Space Commission for international constructive engagement that might look something like this, where you have representatives from Space Force, Space Command, Air Force, other spacefaring organizations that get together in this commission or this intergovernmental IPT to focus on aggregate level national space power problems. Thank you very much for your time today. That concludes my briefing. Thanks.